Hello everyone. So I'll be solving this LeetCode problem today with the title Find the Pivot Integer. So let's take a look at what this question asks us to do. Given a positive integer n, find the pivot integer x such that the sum of all elements between 1 to x, 1 and x inclusively equals the sum of all elements between x and n inclusively. Okay. I see. So basically what it's asking us is we need to find a pivot such that all the numbers before that particular pivot to the left of it should sum to all the numbers on the right of that pivot, right? So let me take an example. I already have this example I printed out. So let's take a look on this array, which is exactly similar to what it asked, right? From n equals to 8 means starting from 1 till 8, find a pivot point where the sum to its left of that pivot should be equals to sum to the right of it, right? So if you see 6 plus 7 plus 8 is 21, and 1 to 6, 1 plus 2 plus 3 plus 4 plus 5 plus 6 is also 21. So 6 is our pivot, right? So that's what it's asked us to do. And then it also says return the pivot integer x, so we need to return whatever that pivot is where the sum of left and right is equal. If no such integer exists, return -1. It is guaranteed that there will be at most one pivot index for a given input. Okay, so it guarantees that there would be at most one pivot index, so it's just going to be one at most, and if it doesn't, then we have to return -1. So let's just think about it. If we want to find all the numbers, so in this case we know that 6 is the pivot point, so we have to find sum of all the numbers before this pivot and sum of all the numbers after that pivot inclusive should be equal. So what I'm going to do is I'm going to use prefix sum, right? So I'll sum all the numbers starting from left one time and starting from right the another time. So you will get something like this, right? So if I add 1 is same, then I add that 1 into the next one. So 1 plus 2 is 3, then 3 plus 3 is 6, then 6 plus 4 is 10, and 10 plus 5 is 15, 15 plus 6 is 21, 21 plus 7 is 28, and 28 plus 8 is 32. Oh, it should be 36. My bad. It should rather be 36. Yeah, now it makes sense. And we are going to do the same thing, but now coming from right side. So from right it's going to be 8, then 8 plus 7 is 15, then 15 plus 6 is 21, 21 plus 5 is 26, 26 plus 4 is 30, 30 plus 3 is 33, 33 plus 2 is 35, and 35 plus 1 is 36, right? So now I have all the sums starting from left and starting from right, and you will observe that actually on the 5th index both the numbers are equal, and that's how we are going to know that this is the pivot. So I'm just going to use the same fact that when we sum all the numbers from left and sum all the numbers from right, there exists an index where the sum will be equal, and that's what we are going to return. So this is essentially my strategy to solving it. So let's just code it out. So let's just make one list called left sum and another list which will hold a right sum. And we also, since we already know what the size of both the list would be, let's just also initialize it with 0. Let's just say we already know that the length of both the lists would be n. So I'm just initializing it with 0, and now let's populate it. So int I equals to 1. Okay, so one important thing is that we should be starting from 1 because that's where the list starts, right? It starts from 1, ends at n. So we already know this fact, so I'll just say it should be less than 1, then add this, and then we also need to have a variable which will just keep track of this cumulative sum. So let's just say lsum over here, and then we need to update lsum. So lsum plus equals to I, and then we are just gonna say left sum of I. Also, just remember, it won't be lift sum of I equals to L sum. It would rather be left sum I minus 1, right? Because we know that the array starts with the index 0, but we are starting with 1, so we need to offset it by 1. So that's why I'm saying left sum I minus 1 is L sum. And I'm gonna do the same thing, just create a variable. This time it's gonna be R sum, which will be equals to 0. And now iteration, in iteration it would start from n, and then it will end as soon as, like, we just check the condition if I is greater than 0, and we'll just keep on decreasing it until it reaches 1. Alright, so now we are going to do the same thing, R sum plus equals to I, and then we'll say write sum, and now the index won't be I, right? Because I starts from n, and our write sum is from 0 till n minus 1, right? Because our list is indexed with 0, so it will go from 0 to n minus 1. So that's why it should actually be I minus 1, and then again we are going to assign it with cumulative write sum, right? And now we're just gonna make another iteration starting with 0 this time, because we already know we are going to iterate both the list. I is less than n and I plus plus. Then we are going to check if left sum I equals to right sum I. We know we already found the index, right? So we can return I, but actually it won't be I. The reason being that right now the index is 0, but we have to return that number, so it would be I plus 1, because it is indexed with 0, and so it should actually not return I, it should return I plus 1. The reason being, if you actually see, since we know the 6 is the pivot over here in this case, so if you actually look, the index of 6 is 0, 1, 2, 3, 4, 5. The index is 5, but the value is plus 1, right? Because it is, in our list we are starting with 1, but in the list is indexed with 0, but our the numbers which we are counting, it starts with 1. That's why we have to add 1. And so if it does not, if this, I think I'm doing it right, yeah. No, actually it should be above this, where returns, we should say return -1, because by default if it doesn't find anything, it should return -1. So let's try to run this. Oops, I did something incorrectly. Okay, I see why it's wrong. So since we are starting with 1, it should actually also include n over here. Let's try to run this. Okay, it did. Let's submit this. Perfect, it is accepted. So okay, let me give a brief overview. So what we are doing is we are essentially creating a sum vector from left and right. So that's the sum vector, that's how it's gonna look, and we are just checking at what index is the value or the sum equals. So we are just returning over here. We do it from left, and this is the left vector, and this is the right sum vector, and then we see at what index. So if you see 0, 1, 2, 3, 4, 5, and from here at 0, 1, 2, 3, 4, 5, at 5 we see the values are equal, and it's gonna be equal, right? Because then your intuition, you should have an intuition, right? Because we are trying to sum this. The condition is that we need to find a point where the right sum and left sum are equal, and that's what we are doing. We'll exactly get the pivot point over here when the value equals. And yeah, it's pretty easy, but it's a good revision of actually thinking about prefix sum, right? Because that's what we are doing. We are just taking prefix sum from left, prefix sum from right, and then we are just using this value whenever, 21. So whenever the value equals, we know that's the pivot point. And yeah, thanks a lot for watching the video. I'll see you in the next one.